Hi everyone. Welcome to another Analytica video from Data Analytica. So today's video is about if you love pandas but your datasets are growing too big for a single machine, then PySpark is your friend. So in this video, we will see how common big pandas operations translate to PySpark and how to scale your workflows effortlessly. So I'm on Databricks free edition and I'm going to create a new notebook. Would like to name it as Pandas to PySpark. Okay. Because we're going to use PySpark, the first thing that we are going to do is let's make it a markdown. And the first thing that we're going to do is PySpark session. So create a PySpark session. Okay. And for this, what we need to do is from PySpark.sql import Spark session. And Spark is equal to, so we already get this suggestion, which actually I'm gonna click on tab and make it active. So here we have Spark session.builder.app name and get or create. So app name, I'm actually just changing it to Pandas to PySpark. And then get or create will create or get an active session. So I think we're good, and then let me just run this cell. So while it's getting connected and while it's running, so let's get our data set. Okay, now it has been already run without any errors, which is good. So the next thing that we're going to do is create a small data set. Okay, so here we're gonna use a columns list with the list of column headers that we will use in that data set. So here I'm using ID, name, age, department, and salary. And next thing that I'm going to use is I'm going to create a list of tuples. So for this, okay, so the list will have, let's say, 5 tuples. Having data for each of these columns in each one. So I'm just randomly filling some data. Okay, not keeping. Okay, so and then now it's department, HR. Okay. So the next thing. Because I already used a similar data set, it's already prompting me or suggesting me those next tuples as well. So yeah. Okay, I'll just click on tab. Okay, so here we have defined, so we have a list of column headers and also like a data list with tuples. So the next thing that I'm going to do is let's run this cell. Okay, so the next thing is to actually load this data. So here the thing is that actually like it's very similar how you do it in Panda and PySpark, but only thing is Spark infers types and partitions the data for distributed processing, because Spark can handle big data, large volume of data with distributed processing. So Spark actually has this partitioning the data for distributed processing, but loading in Pandas is much simpler. But how you do it is very similar actually. So I would like to show you. Maybe here I can. Okay, so let's see how we're gonna do in Pandas. So for in Pandas, we know that, okay, before that, we'll have to actually do this import Pandas SPD. Okay, maybe, yeah. And here, if we need to load this above data to a data frame, we're going to use this pd.data frame and use the data list with specifying that the columns need to take columns from this columns list. Okay, so we are good. And now before running this, let's see how we're going to do that in PySpark as well. So in PySpark, let's say Spark div will have, so instead of the PD, so it's actually using the data frame function in Pandas, we're going to use this create data frame. So this Spark session, so dot create data frame, and here it's no need to specify it explicitly, so we're going to use columns. Okay, so let's run this. Okay, so here we can see that it ran without any errors, and here in Pandas, the df actually returns as ID, name, age, department, salary, which is actually the same in Spark df, so which is good. So here data frame, and then here it's create data frame. Okay, so the next thing that we're going to check is how it's different when we do the data exploration part. So exploring data is actually very important, right? We need to see how the data looks. So in exploring data, Pandas has this head info describe, whereas PySpark has show instead of head, and then print schema, and then describe. Okay, so let's see how we do it in Pandas. So it's a print df.head of 5. We have only 5 rows, and then df.info and df.describe. And let's do the same in PySpark. So PySpark, we need to do is spark df.show of 5, spark df.print schema. Okay, and I'll just, it's already suggesting me print schema and also describe, so I'm just gonna click tab, and yeah, we have what, so we have like all show, print schema, and describe. So let's run this and see how. Okay, so when we look at the results, we get here actually it gives from Pandas we actually get the data frame with all the 5 rows, and then we have info, which actually gives the data columns, and total 5 columns, and what are its d type and non-null count, etc. And then describe, and it gives the data types, int and object, and then memory usage in bytes. But it seems we have info and the header rows here, but we don't have describe. So I'll just click on, I'll just give print, sorry. Because describe is actually something that gives us a statistical summary of the numerical columns in a data frame, which we are missing. So let me give print of div describe, and when you scroll up for the Pandas section, okay, so after the memory usage, now you can see that we have for ID, age, and salary, count, mean, standard deviation, mean value, and the 25%, 50, 75. So all those statistical summary we have. And when it comes to the PySpark, here you can see that it shows the 5 rows, and then we have the info with its d type and other nullable equal to true, so all this different info. And then we also have in the end it's describe, which actually gives a statistical summary. So yeah, okay, so that's it with Pandas and PySpark when it comes to loading of data. So these are actually the changes when it comes to using info in PyPanda or print schema in PySpark. So yeah, so next let's go to the next session. And here let's see how it comes to the selecting columns. When you need to select columns, so what kind of change, what kind of difference in Pandas or in PySpark compared to the other one. Okay, so let me start with Pandas. Okay, in Pandas it's actually like using the double brackets, square brackets. You can easily actually call or select a particular column or columns from a data frame. So let's say here I have df name and salary being selected, but in PySpark it's a bit different. That is, actually we need to show spark df dot select, so we need to specify the option select function, and also if you need to explicitly call dot show to show that. So yeah, okay, let's do it without show. Okay, So here we are. When we run this cell, we get actually just the data frame. It's not showing anything. So we know that in Pandas, you actually need to specify print, and let's run this. And here we get, okay, now it's showing name and salary for that data frame, whereas we can do the same for PySpark using show. Okay, so here you can see that we get actually the df name and salary, and also here we get Spark df returns name and salary. So this is how differs. Like when it comes to Pandas, you can use this double square brackets and easily mention the columns that you require, but in Spark you need to specify columns using select, and yeah, then using print and show you can show those columns. Okay, so we go to the next part where we do the filtering. So let's say we need to filter some rows. Okay, so now we selected some columns, and now we're going to see like filtering rows. Okay, so it's much straightforward in Pandas, I would say. In Pandas, using Boolean mask, so you can actually use the Boolean masks and get the data that you need to filter out. But in PySpark, you need to explicitly use filter function with column objects. Objects. Okay, and here we are. Let's say how we do it in Pandas. We actually can use df age greater than 30. Okay, that's it. It's more straightforward, whereas in PySpark, so first let's import the function that we're going to use from PySpark, because we are going to refer to a specific column. We need to use the call function. So for that, let's import call function from PySpark.sql.functions and import call. Okay, and spark df.filter. The filter, we need to filter the column that is age, where it is 30, and then show. Okay. Okay, so here we have the same results from both Panda and PySpark, but it's just that how we get that result is a bit different. It's more simpler in Pandas, whereas in PySpark, don't forget to use filter and column functions. So, yeah. Okay. So yeah, the result you can see it's just the same. Where here filter call of age greater than 30. Okay, dot show. So I think we can move on to the next part. That is actually, let's say, how do we add or transform a column in Panda, and how we do it in PySpark. So just that we use the same logic or the same thing, but we need to use in PySpark use dot with column, which is quite common when you actually work on PySpark with column function, and also the call function. Okay, so yeah. Okay, so now let's see how we do it in Pandas. Pandas let's say df, I'm going to create a new column called age plus 10. What we do is we actually df age plus 10. So we're just adding a number to that column and we create a new column. Okay. Whereas in PySpark, okay, I'm going to print also df dot head of 5. Okay, so in PySpark, we need to actually create a new, we need to specify a new data frame with the same, or you can use the same name, spark df dot with column, and the new column is going to be age plus 10, and that new column is going to be call of age plus 10, and spark div dot show 5. Okay, so let's run this. Okay, so we get the same, where we can see that the same results in both cases, like age plus 10, where it's actually just added 10 to this age column. So it's just that this with column is you need to specifically use it, whereas in Pandas it's actually more straightforward and simpler. So that's a difference I can see. Yeah. And while specifying that column, use this call function, which has been already imported in this previous cell. Okay, so we discussed with column and adding or transforming columns. So the next thing that we are going to see is an important operation, which is group by and aggregations. Okay, so I would say very similar, both Panda and PySpark. So let's see how it's done. So both uses group by, and then if we need to, let's say we need to calculate the mean salary. So okay, so let's define an operation. So we are going to calculate mean salary after grouping by department. Okay, so in Pandas, how we are going to do is df dot group by, and okay, so department, so we're going to group by department, and then this is the column that we're going to aggregate. And what is the function that we're going to use? We're going to calculate the mean of salary. Okay, so this is how we do it in Pandas. So let's see how we are going to do it in PySpark. Dot group by, here also we use group by, and we use the department dot mean, and then specify which column to use for calculating that mean, and then not show. Okay, so here we have the same result, but how we do it, we actually specify the column before using the main function in Pandas, whereas we using actually the column inside the main function in case of PySpark. So that's the difference, and otherwise it's very similar. Okay, so the next thing that we're going to do, we're going to check is how sorting is done differently in both PySpark and Pandas. So I would say this is a bit different in terms of the function that you use. In PySpark, uses dot order by, whereas in Pandas it is dot sort values. Okay, so let's do sorting in both, and what we're going to do is let's sort salary in descending order. For that, in Pandas, what I'm going to do is df dot sort values. So this is actually the function that I'm going to use, and you need to specify by which column, by salary, and specify whether ascending needs to be true or false. Because we need it in descending order, so I'm setting its ascending to be false. And at the same time, how in PySpark we do it, spark df dot order by call of salary. Okay, in order by itself, you can specify whether you need it in ascending or descending, and here we need it in descending. So I'm using this descending, and then let's try to show this. Okay, so now you can see that if you check the salaries, it has been sorted fine in both cases, but only thing is how it's done, or the functions that we use, they're a bit different. So in Pandas sort values, inside you can specify the by column and then specify ascending equal to false or true, which is simpler than in PySpark using order by and then call which column you need to use and then specify whether it needs to be ascending or descending. Okay, so I hope this will be helpful when it comes to do the sorting. And next thing is handling missing data. Okay, so here I would say it's a very similar, just that the thing, I mean, like it's usually fill NA and drop NA in case of, so fill NA is being used in both Pandas and PySpark, whereas let's say drop NA is used in Pandas. The same thing when it comes to PySpark, it is na.drop. Okay, so let's see in Pandas, df, okay, print of df dot fill na, let's fill it with 0 and let's print it. Okay, so here we had actually like value for all these values. So I think let me just take a null. Okay, so maybe okay, so let me fill, let's say none, or fill okay, here. Okay, let me just copy this create data frame. Okay, so here you can see that I actually had all the data filled before, so that's why now I try to make one of them a none or NA, nothing is there and it's null. So what I'm doing is, if you look at this pandas print df.fill NA with 0, so that none has been replaced by 0, so which is what we need. And also we can do this print of df dot drop NA. So it's going to drop it. So let's see how. Okay, so it's just dropping the whole row and we are not able to see the fifth row. So that's how it's done in Pandas. And let's see in PySpark, spark df dot fill NA with 0, and we're going to show it. Same thing, we're going to do spark df dot drop dot show. Okay, sorry, NA dot drop, yeah. Okay, so if you see, we get the same. It's like the first time it's getting the none is getting replaced by 0 with fill NA, and drop NA just deletes the whole row. Okay, so I think that's just that drop NA gets different to NA dot drop in PySpark. So let's move on and let's go to the next one where we do the joins. So let's see how joins are done. So you know that Pandas has actually mainly uses merge, join and concat. So but on specific criteria, and I would say Pandas can do join on columns, which is actually merge, and then using index on index, which is join. Okay, likewise PySpark, not likewise, PySpark actually mainly column based. PySpark joins are column based, where you need to explicitly specify which columns you're going to use for joining. And so PySpark uses dot join. Okay, so here let's say df1 equal to df, likewise df 2 equal to, I'm just using the same so that it's easier, likewise spark df1 equal to spark df, and spark df2 equal to spark df2, sorry spark df, sorry, and okay. Okay, so we see how we do the join in Pandas. So Pandas, you can actually do that df1 dot merge df2 on, we'll do on id, and we will do how specified as, we'll do inner join. Print. Likewise for PySpark, print, sorry, df1 dot spark df1 dot join df spark df2 comma on equal to id, and we specify how inner show. Let's run this. Okay, so we get the same in both cases. It's just that id name, okay, here name x name y, so it's getting merged, and here also it uses a join, and you need to specify all those to which it's getting joined on id. And Pandas, because it actually differentiates join based on columns, and after specifying the index, then you can use join. And whether you like a concat for a horizontal or vertical concatenation. So there are different types, but in PySpark mainly uses join function and joins on columns, column based. So that's it about joining. Now let's see pivoting, which is also an important aspect. So now let's see how pivoting is done in Pandas and PySpark. So the main difference when it comes to pivoting is in Pandas, it uses dot pivot table function, whereas in PySpark it is dot pivot function. And there is a little bit more difference to how it's done, and I can show you in the next cell when we try to pivot. So let's try to pivot. So pivot df with department, age, and average or mean salary. So that's what we are going to do. And in Pandas, it is a print of df dot pivot table, and the index is going to be department, and columns is going to be age, and then values is going to be salary. And then, like I mentioned, we need to calculate the mean, so the aggregate function is going to be mean. So let's try to run this. Okay, so here you can see that it's actually showing each department, and we have actually like now the columns having age, and then it actually shows the average salary. Let's see how this can be done in PySpark. So in PySpark, it's going to be spark df dot, we need to use group by. So it has to be group by department. And then we use this pivot function where we pivot it on age. And at the same time, we need to calculate mean of salary for values. So now let's try to show it. Okay, so we get the same results, and here you can see that it's just that how it's done, it's a bit different in Pandas and then PySpark. Okay, so the next section that we are going to see is applying functions or user-defined functions. Applying user-defined functions or UDFs. Okay, well, a little bit more to this. So we know that in Pandas, we actually use dot apply to apply something on a column or a data frame, etc. So whereas in PySpark, it's a bit different. Here we need to actually define a UDF or use a built-in function. So we don't directly do this. Okay, so we don't directly use apply. So let's see how it's done. So let's take Pandas case, and here we are trying to apply bonus to the salary column. So I'm going to create a new salary bonus. So here, using the lambda and apply, I'm going to use lambda x is x into 1.1. So we are applying, so we are actually calculating the salary plus bonus by multiplying that value into 1.1. So now here we have salary and bonus, and now let's try to print this. Okay, so here you have actually 10% extra as bonus for in addition to the salary under salary plus bonus, and it works fine. So it's very straightforward, or it's simpler. Now let's see how it's being done in PySpark. So here I'm actually trying to import a built-in function from PySpark. Import UDF, and also from, so I'm going to import a type, double type. Okay, so first we need to define a function, and I'm going to call it as add bonus. So add bonus salary, and it returns, so it returns salary into 1.1. Okay, so next thing is that we actually do a bonus UDF, which is a UDF. Using the UDF built-in function, what we do is we actually use this add bonus function, and then we return it as double type. Now we need to spark df equal to spark df dot with column, and we are having a new column, salary plus bonus, and then we will use this bonus UDF on this column called salary. Now we can try to show this salary df dot show 5. Okay, so here we are with the double type salary plus bonus, and what we do is we just calculate it by multiplying it with 1.1, and we get the same result as Pandas. If you look at the numbers, it looks a bit different because of the type that we defined and also the number here. So so the thing is, when it was just in one-liner for Pandas in PySpark, we need to actually use this UDF, and we need to define a function and also define the return type and then use it on the column. So it actually looks like it has a lot more steps to do, but it is a quite it's not so complex one. So yeah, this is how we actually use a function in Pandas and then PySpark. So that's it mainly about the common operations that we do in Pandas versus PySpark and how it differs. So here I hope you actually got a basic understanding of how it is being done. So what we did, we actually imported data, and we first saw that how it differs when it is in loading. and then we did how it differs when it comes to data exploration, and then in selecting columns. And the next thing we saw was filtering rows. Okay, and next one was adding or transforming columns. And the next one we saw regarding group by and aggregations, how it's being done. Group by, it's very similar, just that we explicitly use this mean of the column, and here it's a bit different. And the next operation we saw was sorting, how it's being done in Pandas and PySpark, using order by and sort values. And then there was handling missing data. Okay, and then we actually saw how joining is being done between two data frames in Panda and PySpark. And then we saw the pivoting. And then the last one we actually saw was applying user-defined functions. Okay, so that's it. And the main thing, let me just write about okay, it's 12th one, and it was actually when it comes to performance and scaling. So we know that Pandas is actually works fine for small data, but in PySpark it's actually is much better with large data sets. Its distributed computing makes it scalable. Okay, so that's it about Pandas versus PySpark, and hope you liked this session, and let me know what you felt about, like when you were doing with Pandas and compared to PySpark, like which one you felt better and straightforward, or why. And so that's it. Let me know your comments and feedback. Thanks for watching. See you in next video.